Hi everyone. Well, thanks for joining. I'm hoping that you guys can see me now and hear me as well. All right, I'm seeing some of you. You're nodding heads. That's great. All right, so this is going to be 4600 Introduction to Computer Graphics. My name is Jen Yüksel. I'm going to be your instructor for this course. Um, so today, my topic is relatively simple. We're just going to talk about the course, how this is going to go. I'm going to talk a little bit about computer graphics. This is going to be a relatively light lecture, and then I'm going to open it up for questions. Right? So that's the idea for today. Just to have an introduction about what the course is. So my camera is over here. You guys are over there. So when I look like I am not looking at you, that's when I'm going to be actually looking at you. So don't feel weird that I'm looking to the side. All right. So first things first. So this course right now, you're all have joined in Zoom, which is great. This is one place where you can see this content and everything. It's nice. I like this. I'll be able to see you. You guys can see me. You can talk, and I can hear. This is all interactive, and I like that. And I like to keep my lectures interactive, so it's all good. But sometimes you might have some quality issues. So I'm not sure how good the quality is on your end. Like when you look at these letters, if they are looking sort of pixelated, sort of blurry in some ways, that means that probably the quality of video that you're receiving on your end is not very good in Zoom. That's what it means. So to alleviate this potential problem, if you're experiencing it, I'm also live streaming these lectures on YouTube. So that's the other option. You can go to YouTube, just go to my channel /live. These lectures are publicly streamed. Let me start by saying that I am teaching this course for the very first time. Now, I'm very familiar with computer graphics, but I haven't taught this course in the past. So the problem for me with that is that I just took over this course a couple of weeks ago. That means I need to prepare the whole content for the entire course. Now, I didn't want to rely on existing content. I actually wanted to sort of redesign this course. So if you guys are familiar with how this course went in previous years, this is going to be slightly different. Of course, there's going to be a huge overlap in terms of content, but it's not going to be 100% overlap. This is going to be my version of this course and how I think this course should be taught. But the caveat for me is that I'm going to have to prepare these lectures throughout the semester. And that's going to have some implications on you. That is, I'm not 100% sure exactly how this course is going to go. I think it's going to go well, but that's not my point. My point is that I may need to shift things around as we move forward when I have better ideas about how this course should be structured, right? All right. So let's jump right into computer graphics. Presumably that's why we all are here. So the three pillars of computer graphics, as I like to call them, that's modeling, rendering, and animation, right? Modeling is the process of generating or the designing as some object, some visual representation of something. This could be a 3D object. It could be something 2D. It doesn't have to be 3D. Modeling is the process where we generate the data that we're going to use for all sorts of computer graphics algorithms. And there are all sorts of tools out there for modeling, and there are all sorts of algorithms and data structures out there for modeling. In this course, we're going to concentrate on the math, we're going to concentrate on the algorithms, we're going to concentrate on the data structures of modeling. We're not going to concentrate on the tools, how to use specific tools. We're not going to cover that part at all. We're just going to deal with the computer science-related part of it, right? The other pillar is rendering. That's the process of generating images. That involves a whole bunch of things. You get the data from the model data, and you generate an image, a 2D image that you look at in the end. So that's the final output that you want to produce in computer graphics. And rendering involves a lot of pieces. In this course, we're going to cover some of the basics. We're not going to go too deep on every little detail. but we're going to cover the main concepts behind rendering, right? The other one, of course, is animation. Animation can be done in various different ways. Of course, with computer graphics, oftentimes we have animating objects, we have moving objects, we have deforming objects, like in this example. And they could be generated in various different ways, and we're going to talk about those in a little bit. So these are the three pillars of computer graphics that we're mostly going to talk about in this course. But this doesn't really cover everything that's going on in computer graphics. Computer graphics is actually a very wide and ever-expanding field, and a whole bunch of other things that can be considered parts of computer graphics besides these three core areas. For example, user interaction is oftentimes considered a part of computer graphics, all sorts of user interaction tools and techniques. Visual reality, obviously, I mean, a part of it is definitely computer graphics. Of course, there are parts that may be arguably computer graphics, maybe not, but you can think about the whole concept of virtual reality as a part of computer graphics. And of course, if virtual reality is computer graphics, then augmented reality is computer graphics too, right? And augmented reality could be something like this: you're just holding a device, or just you're wearing some goggles, that see-through goggles. That's how virtual reality, augmented reality is happening, right? So, you guys know the difference between virtual reality and augmented reality? In the virtual reality, you completely lose your connection with the actual reality. In augmented reality, the actual reality exists, you just add stuff to it. You add some visuals to it. So that's why we're using see-through glasses with augmented reality. Or in the other example, we're using a camera that's actually seeing the actual scene. If we don't see anything at all, if everything is completely covered, that would be virtual reality. All right, let's move on. Visualization is a field of its own, but it's also considered a part of computer graphics. Well, some people do consider it as part of computer graphics. Image processing is another component of computer graphics. In this case, you stop in an image and you manipulate it using all sorts of algorithms. For this example, if you're trying to understand what's going on here, there's some cars at the bottom here, and the algorithm sort of automatically deletes those cars, and they don't exist anymore. So this doesn't quite perfectly fit in our modeling, animation, rendering paradigm, but still, it's considered, image manipulation is considered a part of computer graphics by most people. Another one is, a big one actually, is computational photography. So this is the process of generating photographs, taking photographs using computational tools. So the actual goal here is to take a photograph, but you don't want to just rely on a good old camera, either analog or digital camera, but you want to add some computational tools to be able to do things that you couldn't do with a regular camera. Combining algorithms to enhance the process of capturing images, or being able to do stuff that you couldn't do just by a regular digital camera. Right? This is called computational photography. 3D scanning is definitely a big part of computer graphics. This can be considered a part of modeling, and one way of generating model data could be using 3D scanning tools. And if 3D scanning is a part of graphics, then fabrication can also be considered a part of graphics, right? So in this case, we're taking some models and we're converting them into actual physical objects. These examples are done through knitting. Actually, these were done by hand knitting. They could be done using computer-controlled knitting machines as well. Of course, we could also have additive manufacturing using 3D printers. There's a ton of work out there in computer graphics related to fabrication. Yeah. So all this stuff is considered computer graphics by most people. But let's briefly look at the applications of computer graphics. When I say computer graphics, most people think about entertainment, so let's start with that. The first one is video games. One of my favorite video games here. obviously, video games are a huge part of computer graphics and entertainment. There's really, I'm not going to say any more here. Special effects. Mostly you start with some live action and you add some stuff to it, either some background or some foreground objects. That's considered, a big consumer of computer graphics is also the special effects industry. Special effects can be tools that combine live action, or it could be just purely computer graphics without using any live action shots, none whatsoever, right? That's also considered special effects and a huge consumer of computer graphics as an application. Feature animation is another one. So we typically separate feature animation and special effects because special effects is typically connected to live action. Even if live action does not exist in all scenes, it exists in some scenes, right? There are some actors playing in some scenes at least. With feature animation, we don't have any actors, and the ultimate goal does not always have to be generating realistic images. Most often, feature animation would use more stylized images and cartoonish looking characters, not completely 2D cartoons, but 3D cartoonish looking characters is what feature animation would typically use. Of course, talking about cartoons, computer graphics is also used in cartoons as well. In this example, it's used for generating a background. I'm not exactly sure if this is a 3D background, but it's definitely something that's computer generated one way or another. And then you can have some foreground hand-drawn characters on top of that. This is actually a relatively widespread use case of computer graphics, a relatively widespread use case of computer graphics applications. There are applications that are outside of entertainment as well, of course. So this is an example that's using computer-aided design and computer-aided manufacturing. This is very heavily used in all sorts of engineering applications, as you can imagine. It's definitely a big application of computer graphics. Simulations. Simulations are used for games. They're used for special effects, but they're also used for the purpose of simulation itself. In this case, for example, training pilots, right? So this is another big application of computer graphics. Medical imaging is another big application of computer graphics. But there are various ways that computer graphics is used in medical imaging, as you can imagine. And visualization in general can also be considered an application of computer graphics. Either information visualization or data visualization can also be considered a big application of computer graphics. Well, basically anything that involves some visual component is an application of computer graphics. I would even include our cell phones, right? So, and the graphics on those cell phones. They are a big application of computer graphics. All right. So, enough about general talk about computer graphics. Let's be a bit more specific and get back to this course and talk about what we're going to cover in this course. So mostly in this course, we're going to concentrate on these three pillars: modeling, rendering, and animation. And about these topics, we're going to cover the algorithms, we're going to cover the data structures. So the CG part of it, we're not going to talk about existing tools, obviously. What I would like to do in this course is to give you a broad overview of the important topics in these three pillars. Right? So we're going to cover a whole bunch of topics here. So for most of them, we won't have time to go into too much detail. And this is by design, because in an Introduction to Computer Graphics course, I would like you all to be knowledgeable about all of these things. So this is not a modeling course, it's not a rendering course, it's not an animation course. This is an Introduction to Computer Graphics course that will cover everything to a certain extent. Right? So if you find yourself interested in any of these topics, any of the topics that we covered, you'll find that in the University of Utah we have all sorts of specialized computer graphics courses that dive much deeper into these topics. For example, I teach 2 rendering courses. One of them is about interactive computer graphics, is about interactive rendering and shader programming. The other one is ray tracing for graphics. It's about generating highly realistic images, starting from scratch. And we also have computer animation courses. So if you find yourself interested in these topics, you can find specialized courses in these topics. But in this course, we're going to have a sort of broad, relatively higher level overview. We're going to cover the basics of these topics, right? So this is our textbook. It is recommended, but not required, and there's a good reason for that. While designing this course, I actually had an extensive discussion with Steve Marshall and Pete Shirley. Those are the main authors of this book. And we talked about all sorts of stuff and how this book could be used. I got to tell you that both Steve Marshall and Pete Shirley are two very strong, very well-known graphics researchers. But on top of that, they are people who are really, really good at explaining things. So I'm pretty sure you're going to be happy with this book. And I haven't read the entire book just yet. I've read parts of it, quite a bit of it actually, and I've been very, very happy with it. And I'm pretty sure you guys will be happy with it as well. So we're going to follow this book. Let me actually zoom in. But I'm not saying that this is required, this is recommended. So my recommended style for this course, for you guys to be able to get the most out of this course, would be attending these lectures live, if you can, and listen to these lectures, ask your questions live, and then go back and go to the book and read the related chapter. I'm going to highlight the related chapter. So I'm not planning to cover everything that's in the book, right? And for the stuff that I cover in the book, I'm not planning to cover every detail necessarily. But the book is not going to be a full substitute for these lectures either, because I might actually provide more information or additional information that does not exist in the book. So that's why I would recommend that you use both these lectures and the book at the same time in connection with each other. So this particular introduction lecture is related to the very first chapter of the book. It's not covering everything that's in the very first chapter, but it's covering quite a bit, and it has a few additional stuff in there as well. But actually, mostly I'm talking about how this course is going to go. Right, so you don't necessarily have to purchase the book if you don't want to. We also, as University of Utah students, you should have online access to this book as well. The details are, you can find the details on Canvas. There's a fairly easy way of accessing an online version of this book using your University of Utah accounts. Now, let's talk about these 7 projects. The de facto language of computer graphics is C++, which we're not going to use. So, a lot of people, and a lot of graphics people, actually really don't like C++. I'm not one of them. I love C++. I use C++ all the time. All of my other courses use C++, but not this one. In this course, we're going to use JavaScript, and we're going to use WebGL. Now, I'm not a big fan of Java, but I love JavaScript. Mainly because it works on the browser. It's platform independent, just works on pretty much any browser now. It's reasonably fast. In the past, way back when, it was kind of slow. Today, you can do a lot of really complicated stuff with JavaScript, and it works just fine. So it's and the debuggers are okay, not great, but it's actually pretty decent. I would recommend that you guys use Chrome. Chrome actually has a very good JavaScript debugger. I do use that extensively, and I would recommend it. I'm not sure if there are other good debuggers for JavaScript as well, but we're going to be using JavaScript, and the main reason for that is that first of all, I wanted this to be sort of platform independent. Second of all, I would like you guys to be able to showcase the stuff that you're doing easily. So this is going to be JavaScript, so you can just put it on your web pages and it's going to work, right? Well, I don't want you to be sort of publicly publishing your projects, which is going to be a part of plagiarism. So we're not going to go there. But you at the end of this course, you will be able to easily do stuff with computer graphics and JavaScript, and that's one of my intentions, that you guys will be able to do this. And if you're not familiar with JavaScript, I would say don't worry too much about it, because I think you guys can learn JavaScript fairly easily if you're not familiar with it, and you really should be familiar with it. It's a very, very widely used language, and you guys should know, I think. So we're going to be using JavaScript, and that's going to make things quite a bit easier because we're not going to be battling with the programming language too much. Doing simple stuff in relatively lower level languages like C++ can require a bit more effort. With JavaScript, things are going to be quite a bit easier, and we can use HTML as our user interface, so things are going to be much easier from user interface perspective, right? All right, guys. Thank you all for joining in. We'll do the same on Thursday. So Thursday's topic is going to be some math background, and it's if you want to take a look at the related chapter in the book, just be warned that the chapter 2 of the book is more extensive than what I'm planning to cover. It's covering a lot more math than I am planning to cover on Thursday. So I'm just going to talk about a part of it, and I'm going to talk about the rest when it becomes relevant to the topics that we're covering. All right, thanks for coming in. I'll see you next time.
Thank you.
Thank you.
Thank you.
Thank you.
Thanks.